We're going to continue talking about how we measure energy expenditure, and we're going to still talk about VO2 and VCO2, but this time we're also going to add RER and what that actually means. So, respiratory quotient is just the ratio of carbon dioxide production to oxygen utilization at the cellular level. Okay, but in order to do this, we'd actually have to measure arterial and venous blood gases. Venous blood gases are relatively easy, arterial a little more difficult, and either way, it takes a little bit of time, energy, and effort to do that. Okay, so we don't usually measure RQ. What we do instead is we measure RER, which is the ratio of VCO2 to VO2 at the mouth. So if you remember, the way we measure VCO2 is we just take basically the percentage difference between inspired and expired carbon dioxide, multiply that by the ventilation to give us the amount of CO2 we're producing per minute, and we do the same thing for oxygen, and that gives us an idea of how much oxygen we're using every minute. Okay, and so this is the most common way that we measure or estimate RQ. Now, it's really beneficial, it's a really good measure when we're talking about steady state and sub-maximal exercise conditions. Okay, and we use this to help us estimate fuel consumption. Now, if you remember from our last video, we had a VCO2 of 5.96 and a VO2 of 4.93. So if we went 5.96 divided by 4.93, that gives us an RER of about 1.2. Okay, and we're going to talk about that in just a minute. Now, those are made up numbers, so just so you're aware. All right, so at rest, RER is typically about 0.7 to 0.8 or 0.78 to 0.8. The RER for fat oxidation is 0.7. So if your RER is at 0.7, that means you're just relying solely on fats. If you're relying solely on carbs, your RER can be 1.0. We don't really worry about breaking down protein, but it's in there. And so it's also important to know that this can drop below 0.7 if you're getting glucose from your liver, basically. And it's also possible to exceed 1.00. But again, we'll get into that later. So what actually determines these values? Okay, the simplest way is to go through some chemistry. All right, I'm not going to ask you these equations or anything like this, but I just want you to know where these numbers come from. Okay, and so we've got stoichiometry, which is a section of chemistry that involves using relationships between reactants and products in a chemical reaction just to determine what's going on, to determine quantitative data. Okay, so if we're breaking down just fatty acids, notice that we use 23 oxygen and we produce 16 CO2. So that's where the 16 divided by 23, that gives us 0.7. If we're doing glucose, the reaction is different. We use 6 oxygen, we produce 6 CO2, so we get an RER of 1.0. And so that's where these values came from that we were talking about earlier. But we're not usually just using fats or just using carbs, and so there's there's a scale. Okay? And so the amount of energy that we're using is determined by, well, what percentage are we using from fats, what percentage are we using from carbs. Okay? And again, remember, RER ignores protein, all right? And so if we're just using fats, we're burning 5 calories, or we're using, it costs us 5 calories per liter of oxygen, but if we're just using fats, we're producing 4.6, 4.7 calories per liter of oxygen. Okay, remember that to burn fats actually requires more oxygen than carbs. Okay, and so that's why we're a little more efficient with carbs. Okay, and so what determines how much power or work that we're doing is determined by the activity, right? And so we use this indirect calorimetry to estimate how much energy we're using. So when can we actually use it? And the best answer is during steady state exercise conditions during submaximal exercise. Okay, and so if we're not meeting these conditions, then we can't really estimate energy expenditure. So it's very difficult to estimate energy expenditure during maximal exercise because that's not submax. Okay, and so in order to calculate energy, you need to know 4 things. You need to know VO2, you need to know the RER. You don't need to know the table, but you need to have a table, and you need to know how long you're exercising for. And so the calories that you burn is equivalent to your VO2, okay, so how much oxygen you're using, times your RER caloric equivalent. So basically you find out, okay, my RER at steady state was 0.9, so that means I'm using 4.924 calories per liter of oxygen, and you multiply that by time. Okay, so an example of this is as follows. Let's say that my VO2 is 2.3 liters per minute. My RER is 0.83. Okay, so 0.83 gives me a caloric equivalent of 4.838. And then I was exercising at that intensity for 60 minutes. Okay, so then we go 2.3 times 4.838 times 60. And that tells me I used 668 calories of work during that exercise. Now, how can we determine the number of calories coming from carbs versus fats? Well, it's relatively straightforward. You go back to your table. So we've got 4.838, and we know that 43.8% are coming from carbs. And so we would go 668 times 43.8, and that would give us a value. I don't have it on the slide. And then we could do the same thing for fats. So there's a couple different ways, but you could calculate how much is coming from fats. And so based on VO2 and RER and time, we can actually estimate how many calories we are burning.